Okay, so in this half of the video, we are going to be estimating square roots of non-perfect squares, of imperfect squares. We need to know a couple new vocab words for this lesson just because these will be questions that you are asked. Any number that is not a perfect square is considered irrational, or the square root of a number that is not a perfect square is considered irrational. Rational numbers are anything that can be written as a fraction that have decimals that end and decimals that repeat. So what an irrational number is, and yes, you have to write down the definitions. Irrational numbers are numbers that can't be written as a fraction, and they have non-repeating, non-terminating decimals. That means that it can go on and on and on forever and ever and ever. That's why when people ask me what pi is, I haven't memorized every single digit because it goes on forever and ever and ever and ever. That's why they normally end with like the dots in the end. So every imperfect square, every non-perfect square is going to have an irrational answer. And we're going to see that if you actually try these in your calculator. If you put in the square root of 29, it would go on and on forever and ever and ever. And then you'd have to write down every single decimal. Good news is we don't have to write down every single decimal. We're just going to estimate them. We're going to get pretty close to what that decimal should be. And the way we do that is, one way they're going to ask you is to determine the two positive integers. Square root of 29 falls in between. So the best way, in my opinion, to do this is to create a number line of 1 through 15. And then if you don't have space, 12, 13, 14, 15, and so on. The reason this helps is because once we have those regular numbers on the number line, we can create all of the perfect squares from there. So essentially what we do to create the perfect squares is we write all of the square roots out. 1 squared is 1, so the square root of 1 is 1. 2 squared is 4, so the square root of 4 is 2. So here we have the square roots, and we're creating the radical form of the answer. That way we can compare where the square root of 29 falls in between. 3 times 3 is 9, that's how I got this number. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. It's just kind of helpful to plot this number line at the top of your paper when you're estimating, because see why in just a second what we can do with this information. 8 is the square root of 64. 9 is the square root of 81. 10 is the square root of 100. 11 is the square root of 121. And 12 is the square root of 144. Yes, you draw the number line so you can get used to seeing what this is and what we're doing when we're estimating. So if we're determining the two positive integers, the square root of 29 falls in between, all we have to do is look at our number line, and we see that 29, the square root of 29, falls somewhere in between the square root of 25 and the square root of 36. So the actual positive integers it falls between, square root of 25 is 5, the square root of 36 is 6. So it falls in between 5 and 6. So the square root, having them actually written out, the perfect squares, helps you determine which two perfect squares it falls in between. And then you take the square root of each number to find the two positive integers it falls in between. Good news is you don't have to draw that number line for every single question we do. You could just draw one at the top of your paper, and then we'll use it for every question from this point on. Now we need to determine the positive integers that 40 falls in between. So we're looking for the square root of 40. So we're not looking looking for, like, I'm not drawing all the way up to 40 on a number line. We're just looking for the square roots it falls between. And in this case, it falls between the square root of 36 and the square root of 49. Well, the square root of 36 was 6, and we have that right here. And the square root of 49 was 7, so it falls in between 6 and 7. So that's one way they're going to ask you to kind of estimate these irrational numbers. So because this is irrational, it's going to have those decimals that go on forever and ever and ever. Our job is just to estimate them. If you don't believe me yet, you can check in your calculator and you should get 5 point something, which is also in between 5 and 6. But the deal is you can't really use a calculator when you're taking these on a test or the FSA. This will be on the no calculator portion, which is why this method is so helpful. The next one would be to approximate the square root of 10 to the nearest 10th. That means they want a decimal answer. So our first step is what we just did to answer these two questions. Our second step is to figure out if we should have a relatively low decimal point or a relatively high decimal point. We'll talk about how to decide that. So the square root of 10 falls somewhere between the square root of 9 and the square root of 16. So it falls in between 3 and 4. But that's not what they're asking. They want to know an approximation, like a decimal. So the way we would do that is you always pick the smaller number first, and that's going to be the start of your decimal number. Then you decide if your point, your 10th after the decimal is going to be high or low. It'll be low if the square root number is closer to this perfect square, and it will be high if it's closer to this perfect square. Well, the square root of 10 is a lot closer to the square root of 9, which means you're going to want to have like a really low decimal point. And decimal points go from 1 to 9, so we'll keep it at like a 3.1 or a 3.2. I will kind of accept either answer in that case. So you decide if it's low or high by deciding what number it's closer to. If it's like really, really close to the smaller number, that's when we pick like 0.1 or 0.2. If it's really, really close to the higher number, we would pick like 0.8 or 0.9. Somewhere in the middle, that's when we would pick 0.5. So let's do some practice with this. We're just going to set up that number line at the top again one more time so you can get practice setting it up. So we just create the regular numbers first, and then we build the perfect squares from there. Remember, I'm getting these numbers by multiplying that number by itself, because that's what the opposite of a square root is. So again, like the square root of 64 is 8. That's how I'm getting these numbers. The square root of 81 is 9. Square root of 100. Square root of 121. 144. And then 169. We may need extras towards the end, but we'll see. So these first three examples, we're just finding the numbers they fall in between. We don't have to figure out a decimal. We just need to pick which numbers it goes. So we'll work on this one in green. The square root of 38 falls somewhere between the square root of 36 and the square root of 49. So the two positive integers it falls in between is 6 and 7. It's a little bit closer to 6, but it falls in between those two numbers. The square root of 56, we'll work that one out in blue, falls somewhere between 49 and 64. So it's between 7 and 8. So we just look, figure out what it falls in between, and then take the square roots of those numbers. Square root of 115, that's a bit higher. We'll work that one out in yellow. Falls in between 100 and 121. So it falls in between 10 and 11. Even though we're comparing the square roots to each other, notice how I'm taking the square roots to say what positive integers it falls in between. In the next three examples, we actually have to find a decimal answer for it. So if we approximate each square root to the nearest tenth, that means they want like 3 point something, 2 point something. And we'll talk about how to do each one. You can try them ahead of me to see if you get the correct answer. The first one is the square root of 26. So first we want to find what numbers it falls in between. Well, the square root of 26 falls in between the square root of 25 and the square root of 36. So it falls in between 5 and 6. They want it to the nearest tenth, so we have to create a decimal just to one place after the decimal point. So the way we decide is is the square root of 26 closer to the square root of 25 or to the square root of 36? Well, since it's only 1 away from 25, it's closer to the smaller number, so we would use that lower, smaller decimal, like a 5.1 or a 5.2 or something like that. I would basically accept anywhere between 5.1 and 5.3. If you said like 5.4, 5.5, it's not quite right because it's really, really close to the 5. So it's that smaller end of the decimal points. If we look at the square root of 80, first we decide which numbers it falls in between, but then we have that extra step. So the square root of 80, if we look at our number line, it's not up here. It falls somewhere between 64 and 81. So it falls somewhere between the square roots of those numbers. The square root of 64 is 8, and the square root of 81 is 9. So it falls between 8 and 9. So we always start with the smallest number as the number before our decimal point. The one after is where we start to look where it kind of falls between. It falls in between 64 and 81, the square roots of those numbers, but it's a lot closer to the square root of 81. It means we want like a higher decimal. It's really, really close to the square root of 81, so we would have like 0.8 or 0.9. And I picked a low decimal for this one because it was closer to the smaller number. I picked a high decimal for this one because it was closer to the higher number. You always start though, the number before the decimal point is the lower number, like here, because that's how we write in between numbers. Next example, do in blue. Square root of 180. So I don't think our list up here goes, so we're gonna need to add like a number line from 14 to 15, from 13, 14, and 15. Square root of 169, square root of 196, and the square root of 225. Well, the square root of 180 falls in between 169 and 196. Don't know why I erased it. So it falls somewhere in between there. This one's where it's kind of tricky. 180 is only 11 away from 169, and it's 16 away from 196. So it's a little bit closer to 13, but it's not a whole lot closer. It's kind of close to in between those two numbers, right in the middle. So we would actually have, so it's in between 13 and 14. This is where we would have like a middle decimal point, somewhere between 5.4, 5.5, and 5.6. Because it's a little bit closer to the 13, I would lean more towards the 8 point or the 13.4, sorry. So it falls a little bit closer, so we lean to the 13.4. Okay, this is one last word problem just so we get some more practice with these. Miss Hockersmith is making a square fenced-in area for her dog, name's Pepsi if you don't remember. Surface area of the fenced, I don't know why I didn't write the A's for either of those. The surface area of the fenced area is 121 square feet. How long is each side length? So we want to know, what is this? What is this? What are all of those? Remember, perfect squares are the area of squares. So to find the side lengths, we take the square root of the numbers. Square root of 121 is 11. You can use your list that we wrote down in the very first video, or you can use a number line that we created, either or. Maybe you just know that the number times itself that gives you 121 is 11. So each side length is 11 feet long. Okay, so you'll be practicing this with some homework tonight, so make sure you get that done. Or back to your notes, I'll have extra videos on everything so you can get a little bit more used to all of that. That's all I have for you today.